Right, this is what I call the starter labs, which are portions only of the Unit 1 labs measuring metric system, and then the other one being the pendulum. So let's get started. As I said, you're only going to do for the starter lab portions of that, send that in to me, and then you will get the lab package. So this one has to be in relatively early, and I'll show you what to do, and I don't think it's that hard, really. It doesn't take that much time. So here we go. I'm going to scroll down here a little bit. This is all the theory part and all kinds of instructions there. Here's one thing that I'd like to point out, which are conversions within the metric system. You have these nice conversions, 1,000 gram to a kilogram, and then 0.01 meters to the 1 centimeter, or the other way around, 100 centimeters to the is 1 meters. So it's really easy. In this particular lab, actually, you do come across converting from the American system to the metric system. So you also have the 3.28 feet to the meter. It's relatively accurate. 2.54 centimeters to the 1 inch. That's actually exact. 2.205 pounds to the kilogram, pound mass that is, and so on. 5,280 feet to the mile. Again, you only need it for this particular lab right now. After that, it will be actually just the metric system. Okay, significant figures. You already figured that out, hopefully, in the preliminary lab quiz. You came across that there. So I'm going to scroll down to the parts that I want you to do early on in the semester. And here we go, data and analysis. It will be the parts that I put in green. And so here's one of them. Become familiar with measuring time. So basically for this one here, you only need a timepiece. That can be a clock, a cell phone. Here is my cell phone, respectively an online timer. So I'm going to do this one here. I'm going to walk to the car in just a moment. At the same time, I'm also going to measure the distance, because that's on a later table here. For the distance, I'm just going to pace myself, and then eventually this is also all you need, which is a tape measure, and mine is going to be in inches and in centimeters, so I have a little advantage. You may use one that you have in inches because you might not have a metric one. Okay, so I'm going to make an exception for that. All right, I'm going to walk to the car and measure my paces and so on, come back. But before I do that, I'm going to estimate, I think the car is about 100 meters away, which is about 300 feet. And it's probably going to take me 2 minutes, so I'm going to put 120 seconds here. All right, I'll be right back. Measuring with my timer and so on. See you in a moment. All right, I'm back. And this is what I measured. 174 seconds, 2 minutes and 54 seconds, so a little bit more than my estimate. And this was, by the way, one way. Time to the workplace, I'm not going to do that right now, by the way. Mine would be 6 minutes, so I would put in here 0.1 hours as an estimate. I'm not going to grade you on the estimates. Notice that mine are, not very close, but, it's an estimate. At least I'm in the ballpark. All right, I'm going to scroll down. So again, the green part here, and here's the distance to the car. I estimated 300 feet or 100 meters, but your estimate is probably going to be in feet, so 300 feet. I did measure 480 feet, and the way I did that was that I paced 192 paces to the car, and I know that my paces are 2.5 feet. Respectively, I also measured that, so 2.5 feet. I enter, and because of the two significant figures, well, it's 480 anyway, so I would round it to 480 feet. 2.5 feet, by the way, would be also 0.75 meters. There's 30 centimeters to the foot, 0.75, therefore, meters. And that I multiply again with 192 paces, so I come up with 144 meters, which I'm going to round to 140 because, again, I have two significant figures. The others that you have to fill in here, length of a board, choose any board. For example, if I was doing this now, I would just choose this one here as an incline. I don't have a board in my office. Well, and then you just measure, you estimate. By the way, this one looks like 4 feet or 120 centimeters, and then I measure, and so on. So you would do the same thing, and then the same thing for the workplace, okay? I'm going to get back to these numbers here, by the way, in a little while. Again, notice that my estimate is somewhat off, but then again, it's an estimate. Again, it's in the ballpark. Okay, length of the living room, width, height of the living room. I know it's partially in blue here, but that's okay. So you would have to do that too. In my case, you kind of see my office behind me, so I'm looking at my office here, and I'm estimating its length is about 15 feet. Its width is 10 feet. Its height is 10 feet. So that would be my estimates here. There we go. And then the height. These are my measurements, so I'm going to do that right now. Again, here we go. Here's my measuring tape, and here we go. All right, so I paused the video and I measured this one here, actually in both feet and meters. So this one here is 14 feet and 0 inches. This was here 9.4 feet, and this was 9.3 feet. By the way, I said 14 feet here and no inches because I measured that accurately. It's actually 14.0 feet. Notice actually how my estimates are actually pretty darn good, right? But again, that's a little bit of coincidence. As I said, if you're in the ballpark, that's what you expect of estimates being in the ballpark. All right, I also measured in the metric system for 4.26, 2.87, and 2.84, and of course you would use your own measurements. Now to get from here to here, you would have to go back to one of those conversions from earlier. So let me scroll all the way back up here, and here it is. 3.28 is one of those conversions, or the conversion. Number 2, let's see, so here we go. So if I take but here 3.28 times 4.26. There we go, 13.97, which actually does round to 14.0. 3 significant figures in this case. So you can see where I did measure them, but if I only measured one of them, then that's how I would convert from one to the other. And if you measured 9.4 feet, because you might only have a tape measure in inches and feet, then I would divide that by the 3.28 conversion factor. And there we go, also 2.87 meters. So I actually measured pretty accurately in both systems. All right, then there's a couple of more tables here. I'm just going to do this one here. This is where I would have to go back. Earlier I had 140 meters divided by 174 seconds. 140 divided by 174. There we go, 0.80, so I would get a 0.80 here. To convert to kilometers per hour, well, there is, I think I'm going to put it on this side here. It's kind of hard with the small screen here. So I would divide by 1,000, getting from meters to kilometers, and then multiply by 3,600, because there's 60 seconds in a minute and 60 minutes in an hour. So I would come up with that here. It looks like 2.9 kilometers per hour. When I go to miles, I would have to divide by 1.6. That's the conversion. That was in an earlier page. So divide this here by 1.6 or 1.609, either way. And I come out 1.8 miles per hour. And I walked, I didn't run. So Okay, whoa, okay, this looks really strange. I don't know how that happened here. I'm really trying to get rid of that. Oh, wow. I think I'm going to succeed. There we go, maybe. Okay, to get to feet per second, I think I'm going to do the 0.8 that I had earlier, the 0.80, and multiply by that 3.28. And looking at the significant figures that I had, I think it was only like 2 significant figures, so in this case 2.6 feet per second. And again, I'll let you do that for the workplace. This one down here, I'm only going to do the area. So I look at here, well, my estimates were 15 by 10, so 150 square feet. And then I used the other two numbers that I had earlier, so 4.26, hold on, yeah, 4.26 times 2.87, there we go, 12.2, and in feet it would be 14.0 times 9.4, there we go. So, and this one here would have to be 2 significant figures because of the 9.4. So 132. So I get 132 right here. Again, my estimate is a little bit off, but again, it's ballpark. And then the other number here was, let's see, 12.2 square meters. And then, you know, here you multiply with the third dimension, the height, and so on. And basically, that's actually it, what you have to do for this particular lab as a starter lab. And then I'll get to the pendulum here soon after I take a break. All right, and here's the other part, the pendulum acceleration due to gravity. And here's the theory part. And there's actually nothing to assemble. All I'm asking you for is to do this one here with this applet, which I'm going to show you very soon. And then fill in this table. Notice here is my example. I will try to reproduce actually my example. Let's see what I get. And then you would have to do this for the other links here. So there's nothing to assemble for you. I just want you to do that and go through the motions. All right, I'm going to open this one here. Put in that URL. There we go. Gets me there. Forward. I think I'm going to click on it says lab here. There we go. And there we go. All right. So here's the pendulum. You already saw that my example was at 0.33, so I'm going to get there. There we go. 0.33. And then actually I'm going to go to our Alaskan gravity. It should be 9.82. And of course, as an applet, should be very, very accurate, should be perfect. However, I have to time myself here with a stopwatch. There's the stopwatch, hopefully in the picture. And that means I will have a small error. And I'm going to take the pendulum out. When you read through lab manual, take it out to a small angle because that's where the pendulum formula works for. So don't do this, okay? And I'm going to see if I can stop this one here, and actually that's fine, I think. So only small angles. And here's something important. When you start to count, you actually, well, I mean, when you let go, you actually start your count at 0. You know, so this would be here 0, and then 1, 2, 3, 4, and so on, right? So whenever it returns. I actually like to start it because as I let go here, I would have to move the mouse over here or, you know, try to coordinate that. That's not very good. So I'm just going to let it swing for a little bit. In fact, just like this one here, I could also turn the friction on a little bit. There we go. That's good. And when I'm ready, left or right, I'm going to start on the left. That's when I'm going to say 0 and start the stopwatch. Okay, so here we go. And start. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go, 11.58. Notice actually when I said start, that was also my 0. Okay, and then when it came back, that was 1. Here I can pause it. Sure, here we can pause it. So 11.58. I'm going to get back here. Notice that previously I had 11.56. There we go, 11.58. It was 10 swings. So divide that one here. I can do that in my head. just shift the decimal point, right? 1.158. And then I would have to recalculate this one here for my example. Let's see how close I get to 982. Here's the formula. So that's the pendulum formula. Actually, I'm going to move that, just moved it out of the picture. There we go. Should be back in there. So I'm going to get rid of this here. 4 times pi squared. And, you know, if you have to manually type it in, you type in 3.14 squared. Times, I use 33 centimeters. Which, by the way, that's actually very accurate in here. So they really did have 33.00 centimeters, for example. And then divide by the time, and that was the, I'm going to double check that, 1.158. 1.158 squared, and I bet I get a little bit smaller than I had before. Yeah, I do, 971. So 971, so not super 971, and actually it rounds to 972. There we go. So 972, so not super accurate. Again, I said before, this applet here ought to be perfect, but it's not, because I had to manually use the stopwatch. So that's why I'm somewhat off from that 982. By the way, 982 compared to 972 is 1%, so still pretty good. For the real experiment that you're going to do at a later time, you would have to be also very accurate in there. So this applet here actually prepares you for that. For the starter lap, this is actually all you have to do for these particular lengths here. So change it to 44, 55, and so on, right? So here. And then you start over again with that. There we go. But I'll let you do that then. All right, that's all I wanted to show you. All right, just a little bit. When you're done with your measurements here for the applet, just figure out what the average is. And the published value, by the way, for gravity in Alaska would be 982. That's what I set the applet to. And if you are in Alaska, that's what you would have to do eventually in the real experiment. So here you have 6 numbers here, and you take the average. That's all you have to do as a follow-up. All right, that's it.